Hello everyone. I welcome you all to the e-videos prepared for the Analyst Syllabus under the Regulation 2021. Today we are going to see the session on the topic Operations on Processes from the second unit Process Management in the course CS 3451 Introduction to Operating System. Myself, Dr. C. Rani. The objective of today's session is to know about the operations on processes, and the outcome of today's session, the students may be able to understand the operations on processes. Here is the outline of today's session. There are two operations need to be done in a process. One is process creation and the second one is process termination. Next, we'll be discussing about what is the purpose of fork system call and execute EXC, execute system calls. So here you can see two operations on processes. As we have seen already, there are two types of operating system available. One is multi-programming operating system, the other one is time-sharing operating system. So the processes in most system can execute concurrently. That may be the processes can be created and deleted in a dynamic manner. So we have two operations. One is process creation and the other one is process termination, which is otherwise called as process deletion. So we'll see what is meant by process creation. So during the process execution, a process may create several new processes. When you start executing the process may create several new other processes. For example, you can see the picture at 3. The process A has created two processes B and process C, which we call it as child processes, and the parent process is process B. The creating process is called as parent process, and the new processes which are created by the parent process is called as child process. So each of the new process, which in turn again create the other new processes, which will form the tree of processes. So whenever the process, any process creates the new process using the fork system call. So here, the parent A will create the child process B and C, and the process B will create the child process D, E, and F. And C process will create the child process G. And H is created by the parent process D, and I is created by the parent process H. So the operating system will identify the different number of processes using a process identifier called PID, which is typically an integer value. The process will be created by another process using a system called as fork system call. The creating process is called as parent process and the created process is called the child process. A child can have only one parent process, but a parent process may have any number of children, that is many children. Both the child and the parent process have the same memory image, open files, and environment strings. However, they will have the distinct address spaces. The traditional Unix operating system will identify the process as init system call as the root of all the child process. So here it is init is assigned a PID, that is processor identity ID of 1, and the first process is process created whenever the system is booted. Recent distributions have replaced it with the system. Here you can have the tree of processes for a typical Linux operating system. Here init is a process which is the parent process, which creates 3 child process: login process, kthread process, SSHD process. This PID is a process ID, and the integer value of 1 is assigned to the init process. And the PID value for login process is 84115, and 2 is the PID value of K-thread process, and 3028 PID value for SSHD process. So each and every process can create and in turn create new processes. And each and every process will be referred or identified by a process ID, which will have the integer value. When a process creates a new process, two possibilities for execution exist. The first possibility is the parent continues to execute concurrently with the child process. In the second case is the parent can wait until some of the child process completes its execution. There are two address space possibilities for a new process. The first possibility is the child process as a duplicate of the parent process. When the child process is created, it may be the duplicate of the parent process, whereas it has the same program and data as that of the parent process. Okay? The second case, the child process has a new program. That is, the child process has its own program which will be loaded into the memory for execution. When a child process creates it, when a process creates a child process, the child process will need certain resources like CPU time, memory, files, I/O devices to accomplish or to perform its task. The child process may be able to obtain its resource directly from the operating system, or it may be constrained to a subset of the resources of the parent process. That is, the child process may get its resources directly from either from the operating system or from the parent, some of the resources from the parent process. The parent may also have to partition its resources among its children, child process, or it may be able to share some resources like memory or files among several of the children. The purpose of fork system call is to create a new process which becomes the child process of the caller. After the child process is created, after a new child process is created, both the processes, both the parent process and the child process will execute the next instruction following the fork system call. Therefore, we have to distinguish the parent process from that of the child process. So either processes can be identified by, we can refer it by using the processor ID. So this can be done by testing the return value of the fork system call. Here you can see the whenever the new process, that is the parent process, creates the child process, the PID value, the child process will be created using the fork system call. Okay, and each and every process will be having the PID value, that is processor ID. If the processor ID PID is 0 integer value, we call that as a child process. If the processor ID is greater than 0, that we call it as a parent process. It can move to the wait state. After the IO interrupt occurs, it moves to the wait state and the parent resumes. Okay. And here you can see, after the child process is created, it can execute its own instruction, or it can execute its own program code using the system called EXE system call. So after all the child process is completed its execution, it moves to the exit state, and then the parent process can resume its execution. So here you can see the Unix C program in which a process can be created. Here you can see this statement. a child process is created using the fork system call, and 3 cases are possible. If the PID value is less than 0, it means that some error has been occurred, and the standard error which will print fork is failed and returns the value. If the PID value is equal 0, it means that the child process is being executed, is being created, and the child process can go on executing its own program code using the exe system call. Here you can, the statement has 3 parameters. The first one is the location, the area from which the code is executed, from the bin/ls. Okay, the command need to be executed is list, that is ls command, and null value. The third parameter is null. If the third case is the parent process will wait for the child to complete. After the child completes, the parent resume its execution. The second one is the process termination, or otherwise called as deletion. Okay, a process terminates when it finishes its execution. Finishes its executing the instructions and asks the operating system to delete it using the exit system call. Okay, so at that point, the process will be returning a status value, that is, any integer value will be returned to its parent process using the wait system call. So all of the resources of the process, including the physical memory, virtual memory, open files, and IO buffer values, will be reallocated by the operating system. Once it finishes its execution, the process gets terminated or deleted. It means that we need to delete, or we need to deallocate the memories which is allocated here. That deallocated process will be done by the operating system. The parent process may terminate the execution of one of its children process for a variety of reasons. The child process has exceeded its usage of some of the resources that it has been allocated. The task assigned to the child is no longer required. The third case is the parent is exiting. If the parent process is complete its execution, then the operating system does not allow the child process to continue if the parent process terminates its execution. Okay. Only way that if the parent process continue its execution, only the child can continue its execution. If a process terminates either normally or abnormally, then all its children must also be terminated. That is, if the parent process terminates, then all its children process may also be terminated. This phenomenon is referred to as cascading termination. And this cascading termination will be initiated by the operating system. And these are the references used for preparing the slides. Thanks for watching. Thank you.